What is LIN? LIN stands for Local Interconnect Network. In its simplest form, a LIN network consists of a LIN master and a LIN slave. Data is exchanged encapsulated in data frames with a fixed structure. These data frames always contain a break field that indicates a new incoming frame. A sync field that allows the slave to synchronize on the master clock. The message ID field from which the slave knows how to interpret the forthcoming data. A data field containing the communicated data bytes. A checksum ensuring correct reception of the data frame. Two types of message can be distinguished. Transmit frames, which contain data sent from the master to the slave, and response frames, which contain data sent from the slave to the master. In both cases, the header part, containing break, sync, and message ID, is generated by the master. The data part, including the checksum, can be generated by either master or slave, depending on whether it's a transmit or a receiving frame. In this example, a LIN-based switch module has to communicate the switch status, open or closed information to the master. The master informs the switch module of the applicable PWM value for the indicator LED. Each LIN master has its schedule table that defines the sequence of messages that will be transmitted on the LIN-bus. Typically, messages are transmitted at a fixed interval, the so-called tick time. At 20K baud using frames with 4 data byte, the tick time is 5 milliseconds. In this example, the schedule table consists of 2 messages, one response frame that contains the switch status information and a transmit frame that contains the PWM value to set the brightness of the LED. The master runs continuously through this schedule table. When the switch is pressed, the slave will convert this physical action into a bit value in a register. When the master sends out the message ID of the response frame, the slave will put the content of this register into the data byte. The master will update the PWM value for the function light in the next transmit frame. The slave will update its LED driver output accordingly. As long as the switch status register in the slave remains 1, the corresponding bit in the response message remains 1 as well. When the switch is released, the register will be reset to 0 and the data in the next response frames will be 0 as well. As long as the master does not update the LED PWM information, the LED remains on. In real life, this whole process runs so fast that the user experiences instant reaction. A typical switch module consists of multiple switches and LEDs which are all controlled from the same LIN slave. One slave can have multiple transmit and receive frames. The LIN master can manage up to 16 slaves on one bus. The message ID field will define which of the slaves will react to the transmitted message. Typical LIN masters are the door module, the steering wheel module, the HVAC controller, and the smart junction box. When the schedule table becomes too long, or if the number of slaves is too big, one LIN master can also control multiple LIN buses. A major benefit of the simplicity of the LIN network is that software development can be avoided. Simple LIN slaves that act as I/O extensions in switch modules can be configured quickly and simply by configuring the data E2PROM during end-of-line programming. This is demonstrated using the example of steering wheel switch module. The I/Os of the LIN slave are configured for 4 single switches to ground, 2 rotating encoders, 3 PWM outputs for functional lights or backlighting, and 1 analog input. The switch debounce time is set to 20 milliseconds. A first slave-to-master message is configured with 4 data bytes. The switch information is assigned to byte 0, the analog input is assigned to byte 1, and the rotating encoder values are assigned to bytes 2 and 3. A second master-to-slave message is configured with 4 data bytes that are configured for receiving the 3 PWM duty cycle values. In a similar way, for a door switch module, the LIN slave can be configured to read more than 20 switches in a matrix. The LIN slave can wake up the LIN-bus when any of the switches is pressed. Avoiding software development also implies guaranteed quality without software validation and qualification. The LIN standard allows vehicle manufacturers to add functionality and extend comfort packs with minimum development cost and to react faster to new requests in the market.